are in an 11 Wrangler. It has a Generation 5 LT L86 6.2 liter direct injected engine. This is GM's latest model truck SUV engine, and it has a lot of power and a lot of torque. This JK is pretty light, so that makes this engine in this JK quicker than a lot of the performance engines like the LS3s and the 6.4 Hemis. This is the future. This engine has continuous variable valve timing, which means it can phase the cam anywhere it wants, anytime it wants. It's not discrete where it's just on and off. That gives you better control of cylinder pressure and emissions like NOx emissions, which are created under high cylinder pressures. This engine has direct injection, which allows better fuel control and spark control. This engine has 4-cylinder mode, air fuel management, displacement on demand, whatever you want to call it. It's all in an effort to get economy, but the difference with this L86 is just how much power they have. This engine can put out over 300, I believe over 350 foot-pounds of torque just off idle at about 1500 RPM. That's more torque than the V6 has anywhere, both the 3.6 and the 3.8. And when you get this engine up into its power band, it's well over 400 foot-pounds of torque. This engine right off idle will pull 40s like nothing. It's like a diesel. And if you gear properly with this engine, you can cruise on the highway well below 2,000 RPM and still have plenty of power off the line. Cold, wet morning here in Vegas, and we're continuing our test drive to the mountain. Continuing our talk on the LT motors, since they're going to be the engine that we need to install in the future. Let's talk about their technology. Really, an internal combustion engine versus an external combustion engine. External combustion engines would be like a steam engine, where pressure is produced outside of the combustion chamber, let's say in a boiler, and then it's pumped into the engine, and it pushes the piston down and up in most steam engines. But in an internal combustion engine, we can only be so efficient. Internal combustion engines in general are most efficient at wide open throttle with no restrictions in the intake or the exhaust. Obviously, we can't run an IC engine wide open throttle all the time, so we have to throttle it, and it's the part throttle that's the problem. Part throttle causes what's called pumping losses. Pumping losses usually come from the piston fighting internal pressures and vacuums, and the larger displacement the engine, the higher the pumping losses. So manufacturers have approached this in a couple of different ways. One is to make the engine smaller displacement, but when you do that, you lose torque. When you lose torque, you move the ability to move weight efficiently. Now, yes, you can supercharge, turbocharge, and all that. You can even go to a diesel. But the bottom line is most of us want to drive a big V8. We like the feel, we like the sound, and the reality is they moved the JK the way it was supposed to be, or at least the way we expect it to be. Traditionally over the years, and I'm talking about growing up in the 60s and 70s, if the Americans wanted more horsepower, we just make the engine bigger. We went from a 265 to a 283 to a 302, 327, 350, 400, 427, 454. We just kept making the engines bigger. The Europeans, on the other hand, would make their engines more advanced. They'd add a second cam, maybe go to dual overhead cam or 4 valves. They would do it through technology. Let me tell you, this L86 and this lightweight JK is pretty funny. This thing is just like a skateboard, barely touching the throttle. So the Europeans would do it through technology, where the Americans would just do it through brute cubic inches. Problem is, when the gas crisis hit and emissions and everything else came into play, large displacement engines that were burning dirty didn't work anymore. So there's a couple of different approaches. Going to the small displacement engine, turbocharging, supercharging, works, especially if it's manufacturer supported. Because if it's not manufacturer supported, sometimes you can have problems with the calibration, surges, hesitations, cruise control doesn't work right. Going with a large displacement engine is great, but you usually lose economy. Over the last 20 years, things have really changed with efficiency and performance in internal combustion engines. Growing up with the old small blocks and big blocks, they were great for what they did, but the combustion chamber technology and emissions technology, we used to run secondary air systems to complete combustion in the exhaust manifolds, to reduce the HCs and the COs. We'd run EGR valves, exhaust gas recirculation valves. Back in Los Angeles when I grew up, it was a Los Angeles is a basin, and you see that brown haze. It was the formation of NOx. We kept leaning motors out thinking they were going to be cleaner, but really all we did was cause the creation of NOx, so we had to recirculate exhaust gas into the intake to dilute the mixture and cool down the combustion chamber to reduce the formation of NOx. So we learned a lot, and the modern LS and LT engines and the other engines out there have taken advantage of this technology, and the end result is we're getting 400 plus horsepower V8 engines that are running more efficiently than the small engines of 20-30 years ago. Getting back to the pumping losses, by going to a larger displacement engine and suffering those pumping losses means it's inherently not as efficient as a smaller displacement engine. But the smaller displacement engine is inherently not as efficient as the larger displacement engine in a big truck. You wouldn't put a small 2.5 liter gas motor in this truck right here. Sure, it would move it, but it wouldn't move it very well. So the different approaches are, you can put a small engine in, which is Jeep has chosen to do, and they've been very successful at that because really the Wrangler has been intended to be an off-road vehicle. 2007, when the Wrangler went to a four-door and really became a family vehicle, it changed its purpose, in my opinion. It went from just being an off-road vehicle with an engine large enough to get it to the trail to a family SUV that you could load up and haul your family and all your stuff out to the trail. This meant that it had to travel on the highway and keep up with traffic. So you wanted to go 75, 80 miles an hour in your Wrangler where it's legal, and the little V6 just couldn't do it. Then you mod your Jeep, you put 35s on it, 37s on it, bumpers, winches, and the next thing you know, you're not keeping up with traffic. It made sense to put a V8 into a Wrangler. Most of you know that MoTech pioneered the Gen 4 swap back in 2007. We had fully functional Gen 4 swaps over 10 years ago, when most of the rest of the industry was going with the Gen 3 swaps. Most of you know that we pioneered the Gen 5 LT swap back in 2016, and we've done dozens of LT swaps since. The LT swap is going to be the future in the JL. It just has to make sense. The Gen 4s are out of production, mostly out of production. They're still making the 6 liters. They made the 6.2 up through 17 in the Chevrolet SS. I don't think they're going to continue it beyond 17. That was kind of an oddball Holden-based platform, but you never know. There might be something trickle through. But in the meantime, the LTs are carrying the torch. We're going forward with these LTs. They're efficient and they're awesome engines. So what they've done to make these V8s efficient is, one, multiple displacement. What that means is they take cylinders and they basically shut them off. They disable the lifters so that the piston becomes an air spring. They don't suffer the amount of pumping losses as if that cylinder had been operating in a 4-stroke mode. These pumping losses are mostly seen at part throttle, which is where you operate your vehicle most of the time. So DOD and MDS, AFM, whatever you want to call it, essentially what you're doing is taking your large displacement engine and turning it into a smaller displacement engine for efficiency. And it actually works pretty good. And I will say it works better on these Gen 5 engines than the Gen 4 engines, because the Gen 5 engines have better control of cylinder pressure, and that's really what it comes down to. What I mean by that is the Gen 4 engines, you can get, let's say, an LS3 with close to 11-to-1 compression, has good high cylinder pressure, puts out good power, but you got to run premium gas or the engine's going to knock. You can run lower grade fuels in pretty much any engine, but the octane scaler is going to bring the spark timing back, and you're going to suffer power and economy losses. In engines designed for lower grade fuels like the 6 liter and the 5.3, their combustion chambers are designed for the lower grade fuel. They have lower compression ratio, therefore the octane's not as critical, and you can get decent economy out of those engines. You put premium gas in a low octane engine and you're going to see some performance increase and some economy increase, but not like if you put it into a high compression engine. I do recommending a higher grade of fuel in the 5.3 and the 6.0s if you're going to go, let's say, to Colorado, run the Eisenhower Pass towing a trailer. That's a lot of load. You want to increase your octane. Getting back to the Gen 5 has very good control of cylinder pressure. One, we have high compression inherently because we're running direct injection. Direct injection allows better fuel control in the combustion chamber than injecting the fuel into the intake manifold and have to go by the intake valve. Two, we have continuous variable valve timing, and continuous is the part that's important. We've had variable valve timing for many years, in the LS engines, but it's discrete. It's basically on and off. So you have two operating ranges, low speed and high speed. You can feel on the 6-liter when that cam phases at about 3,000 or 4,000 RPM, you can feel that extra burst of energy. But the reality is, above or below that phase point, you're pretty much stuck at whatever your cam timing is. Therefore, your spark timing and RPM become critical for engine performance. Now, with the Gen 5 LT motors, where they've stepped it up, is they can phase the cam anywhere they want, whenever they want. And by doing that, that means at low RPM throttle, if you're under a light load, it can really bring that cylinder pressure up for better cruising economy. But then when you get on it, it can retard the cam to get the power that you want. It can control the cylinder pressure for the output of the engine. Doesn't matter if you have a JL or even if you have a JK. If you want the best maximum performance and economy, you're going to have to go with the LT engine eventually. Do I like the Gen 4s? Of course I do, but I also like the small blocks and the big blocks. I did a lot of work with those. I grew up a hot rodder in California, and innovation in the hot rod industry is not lacking, but OE manufacturers have restrictions. OE manufacturers have to meet government regulations, and when you have to meet emissions and performance regulations, it really changes the game. Anybody can take an engine and throw spark and fuel at it and make it run better. Anybody can take an engine, put a turbocharger or a supercharger on it and make it put out good horsepower. But when you have to meet the longevity requirements, an engine that has to go hundreds of thousands of miles because of warranty, it has to meet emission standards because the federal government is mandating these emission standards. I remember back in the 80s and 90s playing with lean crews and increasing fuel economy 20-30%. Lean crews has been banned in North America because of NOx emissions. So these manufacturers are really under a lot of constraints for performance and economy, and I think GM did an excellent job maintaining the performance, and so did Ford and Dodge. They're all doing a great job. If you look at the engines that are out today, we couldn't dream of these engines 30 years ago. I remember big block Chevys that were 400 and 500 horsepower idling at 1,300 RPM so they didn't stall, and putting out so much hydrocarbons at the tailpipe your eyes would water. Now we've got small blocks putting out 400 horsepower, burning very clean. We are currently doing some mods to these Gen 5 motors. We're putting the performance cams in and eliminating the AFM. AFM can be a limiting factor. If you want an engine that's going to get you around town, the AFM and DOD are great. If you have a very heavy JK, AFM and DOD are not going to do you a whole lot of good. And going back to what I mentioned earlier, I believe the reason the DOD works a little bit better in these engines, in the Gen 5 engines and the Gen 4 engines, is having that extra cylinder pressure means you can stay in the 4-cylinder mode longer and not kick out. Remember, 4-cylinder mode doesn't do you any good if you don't have enough torque to move the vehicle. It's going to revert to the 8-cylinder mode. The problem with a smaller displacement engine is you don't have that option of reverting to a larger displacement. You're stuck. So you have to rev the motor up to get power, put a supercharger on it, or whatever. But with a larger displacement motor, it's going to switch between the 4 and 8-cylinder mode based on your need. If your need is too high, like in a heavy JK with 40s, AFM is not going to do you very much good. If you have a light JK like the one I'm in, or like the one my wife drives, she's in 4-cylinder mode all the time, and we get excellent economy. So effectively, we're taking the advantages of a smaller displacement engine by reducing the displacement of a larger displacement engine using AFM. AFM is more effective because we have higher cylinder pressures due to the direct injection in the VVT. Now, all this technology comes at a cost. One, the complexity of the engine, and two, the actual cost. GM is cranking these motors out by the million, and just like the Gen 4s that had teething problems early on with oiling systems and AFM, so do the Gen 5s. Some of the Gen 5 motors had recalls for the lifter manifold assembly and lifters. A lot of guys are just ditching the AFM and going to the camshafts, and they just put out so much horsepower. I'm told you can pick up 90 to 100 horsepower in an L86 just by changing the cam and ditching AFM, and that's amazing. If you drive an L86 and right off the line you feel that torque, you never want to go back. You never want to go back to an engine that you got to push the throttle and wait for it to rev up to get the output that you want. GM has torque management built into these engines that reduce throttle response, but of course all that's adjustable. So having an engine that puts out over 500 horsepower, that runs clean, that will idle at 500 RPM and crawl all day, is really something that we never considered or dreamed of 20, 30 years ago, but it's here, and it's the LT engine. We're going to be putting the LT engines in the JL. Personally, I think the 5.3 is more than enough. The L83 LT engine has got well over 300 horsepower, but it has the technology that gives it tremendous torque. When it comes to the transmission, I'm still on the fence. I like the 6L80, I like the 8L90. There's some qualifiers with the 8L90. The 8L90 has got more gears. The gearing is slightly more diverse. We got a 4.6 low and a 0.60 overdrive versus a 0.67 overdrive and a 4.0 low. So it's slightly more diverse, but you got 2 more gears within that gear range. So you have to gear properly. That means you can't run 538s on 35-inch tires. You're going to be shifting constantly up and down. You have to get your mind out of that mindset of gearing with a V6 and gear tall. If you gear an 8L90 tall enough, I think they work great. You can cruise on the highway at well under 2,000 RPM and still have enough torque off the line to fry the tires. On the other hand, the 6L80 is still an amazing transmission for me. It's a clutch-to-clutch, low-friction, low-heat transmission. It's adaptive, so it learns how you drive. It has multiple modes: second gear launch, maximum gear set, gear lock. I think the 6L80 has a perfect amount of gears for a JK, because JK is basically a 0 to 90 mile an hour vehicle. Not many guys cruise over 90 miles an hour. So 7, 8, 9, and even the new 10-speed coming out, I'm kind of on the fence on those. I know it's about economy, and we've got most of the gains that we were going to get. 1999, the Gen 3 engines really made a huge improvement over the earlier small blocks. The combustion chamber technology, the lightweight construction, we had double-digit increases in performance and economy. Gen 3 to Gen 4, not so much. Gen 4 to Gen 5, not so much. But every generation, of course, we are getting better. The 8-speed, I believe, is only rated at 2 or 3% better efficiency than the 6-speed. That's not that much. And personally, I think 6 speeds is enough. Let's talk a little bit about this build. This is a 2011. 2011 is a good year, in my opinion. 2011 had the new interior. So if you want the new interior, but you don't want to spend the money to get the Pentastar JK, because the Pentastar JKs do go for a premium, get a 2011. I personally like the old interior. I like the utilitarian feel of the early JK interior.